Good afternoon. Substrate level phosphorylation versus oxidative phosphorylation. Compare and contrast these two terms. This is an important question asked in examinations and very important for your understanding of the subject also. To understand these, first we concentrate on substrate level phosphorylation. Have a look at these two equations. The first one, phosphoenol pyruvate is getting converted to pyruvate. And in this reaction, ADP and phosphate, they combine together to form ATP. This is the terminal, the last reaction of the glycolytic sequence, you all know. And this is a reaction of TCA cycle, another example of substrate level phosphorylation. यहाँ पर succinyl coenzyme is converted to succinate and concomitantly there is production of ATP. Why these two reactions are able to generate an ATP? The reason you can understand from this equation, ADP and phosphate, they can form ATP only when there is input of energy. This is an endergonic reaction. And when input of 7.3 kilocalories per mole, then only there can be formation of ATP. Simply stated, phosphorylation of ADP by phosphate to form ATP occurs, and this is an endergonic reaction where input of this much of energy is required. So this 7.3 kilocalories per mole, this is the central figure. We also call it free energy of ATP hydrolysis. Of course, when ATP will be converted to this, itni energy release hogi. So coming back to the point, whenever this much of energy is available, phosphorylation can occur, ADP or phosphate से ATP बन सकता है. Why phosphoenol pyruvate is able to generate ATP, can cause phosphorylation? Because it is what we call a super high energy compound. It lies very high on the thermodynamic scale. And when it is hydrolyzed, converted to the, sorry, not hydrolyzed, converted to the next product, it generates more than 7.3 kilocalories per mole of energy. And this energy can be used for generation of ATP. More than 7.3 kilocalories energy is released. Likewise, this is a reaction of TCA cycle. Succinyl coenzyme also it is super high energy compound. When it is converted to the next intermediate, more than 7.3 kilocalorie energy is released, which can be used for formation of ATP. So in both these reactions, phosphorylation is occurring at the level of substrate. When the substrate is transformed to the next product, ATP generation is occurring. That is why it is called substrate level phosphorylation. So one important point, ADP, phosphate, they are not important. Energy is important. इसीलिए जब glucose 6 phosphatase is converted to glucose, no ATP can be generated because glucose 6 phosphate is not a super high energy compound. So we have done substrate level phosphorylation. Now we come to oxidative phosphorylation. This is more complex, more tedious, prolonged, lengthy, whatever. Just TCA cycle is the final pathway, final catabolic pathway. And the most important products of TCA cycle, energetically speaking, are reduced coenzymes such as NADH and FADH2. They both are reduced coenzymes. So they both carry a reducing equivalent, pair of reducing equivalent. Now, let's focus on NADH. NADH is capable of donating its pair of reducing equivalent to the electron transport chain. All of you are very well aware of this electron transport chain. And these electrons, when they enter the electron transport chain from NADH, they are energy rich. Energy content is very high. And as they travel down the electron transport chain in a stepwise fashion from one carrier to another, they release their energy. And finally, when they emerge from electron transport chain, they have lost most of their energy. Where has that energy gone? That energy has been utilized for phosphorylation of ADP to ATP. In other words, this energy has been used for formation of ATP. So here you can see that the oxidation, actually it is redox, but we call it oxidation, electron transport chain, this is oxidation reaction. तो ऑक्सीडेशन से जो एनर्जी रिलीज हुई दैट इज यूज फॉर फॉर्मेशन ऑफ एटीपी दैट इज यूज फॉर फॉस्फोरिलेशन so oxidation coupled closely with phosphorylation, hence this term oxidative phosphorylation. So in contrast to substrate level phosphorylation, it is much more lengthy, much more tedious, much more complex, but more rewarding also. Finally, just a viva question. Can you call it substrate level phosphorylation? Yes, because creatine phosphate it's a super high energy compound. So it can generate ATP from ADP and phosphate. So it is commonly said by students in vivas, etc., that creatine phosphate, it stores energy. What does that term mean? It is a super high energy compound, therefore can generate ATP by substrate level phosphorylation. So that is why we call that it stores energy. That's all. Thank you so much.